Welcome to qnawire.
So here you can see in B there is two supports, that is this support will cause BH and this support cause this reaction BY, and in joint A there is one support and that cause AX, a reaction along X, and here this is a pinned support. So because of this type of support there will be three reactions along X, Y and Z direction. Now the truss is symmetrical about XY axis, so we can solve only for half the truss and the other half will be same. Now from symmetry, from symmetry here we can notice that Bx will be equal to Dx and By will be equal to Dy. And now let's apply equilibrium equation in this 3D. So summation at momentum x along x direction equal to 0 gives you. So first let's do along y. First let's do along y. So this gives us the 24 feet, 24 into this 400 lb plus the 10 feet into ax, that is the distance here. This distance is 10 feet into ax, 10 feet into ax will be equal to 0. So from here we can write the value of ax will be equal to 960 lb. So we got the value of ax. Now let's resolve along x. This gives us bx plus dx minus ax equal to 0. We know the value of ax. So and from symmetry, yeah, oops, from symmetry the bh is equal to dh. So the bh is equal to dh. So if we consider only bh, 2 bh, ah equal to 2 bh. So we therefore bh will be equal to ah divided by 2, that is 960 divided by 2, that is 480 lb. So bh equal to dh equal to 480 lb. Now summation along y equal to 0 gives you by plus dy equal to this 400 lb, and we know from symmetry by equal to dy, so 2 dy equal to 400, so that means by equal to dy equal to 200 lb. Now we got the reactions. Now let's solve. At joint C connects member AC, BC and DC. So here you can see joint C connects members AC, BC and DC. So Let's calculate the distances first. Like AC will be equal to root of oops, root of 24 square plus the 10 square, 10 feet plus 0. Yep. And this value is 26 feet. Yeah. Now about BC. Let's calculate the distance of BC. That will be 24 feet square plus 0 square plus 7 feet square. That is equal to 25 feet. Now about CD. Let's calculate the distance of CD. That will be 24 feet square plus 0 feet square plus 7 feet square. And this is equal to 25 feet. And now let's calculate the forces. We got the distances. Let's start with FAC. So FAC will be equal to actually the vector FAC. The vector FAC will be equal to the magnitude of FAC AC by AC. So FAC, and we calculated the value of AC, that is 26. 26 multiplied by 24 I plus 10J. So, and FCB, the vector FCB, let's do the calculation here itself. The vector FCB equal to magnitude of FCB into vector CB by CB, that is FCB. We found the value of BC, that is 25, into 24I plus 7K. K is the component element set. Now FCD equal to FCD CD by CD, vector CD by CD. So FCD by CD is also 25 multiplied by 24, the H component, minus 7 Z component, yeah, I is X, J for Y, K for Z. So the component at J direction, so that is the component at J direction, that is summation around Y equal to 0 gives you the 10 feet by 26. FAC minus 400 equal to 0. That is, you can see from joint C, like, yeah, let's draw the diagram for better understanding. Like, if this is C, then at C there is a 400 lb, and the yeah, this is F AC, this is F DC, this is F BC. Okay, yeah, and yeah, let's the directions also. Like, this is Y, this is actually Z, and this is X. Okay, yeah. Now, yeah, from this diagram we got this one along Y. Yeah, okay. Now from here we can find the value of FAC. FAC, therefore FAC will be equal to 1040 lb. And you can see here FAC is going outward from the point C, that creates tension. So let's denote it by the letter T. Now, component at K direction. Component at K direction, that is, so let's summation along Z equal to 0. So 7 by 25 into, we will get, that is common for FBC and FCD, equal to 0. So from here this will be 0, so FBC will be equal to FCD, FBC will be equal to FCD. So that means, yeah, so here we get an equation, right? Therefore FBC will be equal to FCD. Now let's look into the component at the remaining is I direction, right? Yeah, I direction. So for that, summation along X, yeah, summation along HVT. So this gives us the 24 feet divided by the 26 we calculated times FAC plus again 24 divided by the hypotenuse 25 times FCB plus the 24 divided by 25 FCD equal to 0. So here we know the value of FAC. We already got the value of FAC, just substitute that value. So 1040 into 24 by 26 gives us 960 plus the other values, the 24 by 25 times FCB, right? Yeah, plus 24 by 25 times FCD equal to 0. So we got two equations, like from here FBC equal to FCD, just substitute that here. So that means from here we can write FCD. Yeah, you can just, like, if this 960 goes to right hand of the equation, that will be minus 960, and we can take common this 24 by 25. So take common that 24 by 25. So if that 24 by 25 goes to right hand side, that will get reciprocated. So now the resulting right hand side will be 960 into 25 by 24. Okay, yeah, 960 into 25 by 24 is actually, yeah, that will be minus 960. So minus of 960 into 25 by 24, that is 500 lb. So yeah, uh, yeah, so we know the FBC equal to FCD, so that is equal. So if that is equal, the 1000, the right hand side 1000, that is 960 into 25 by 24 is 1000. So 2 FCB equal to 1000, then FCB equal to 1000 by 2, that is 500. Okay, yeah, FCB equal to FCD equal to then minus 500 lb. And you can see here FCB, and FCB is actually going outward, but the sign here is minus, that indicates the actual direction is opposite to the direction we have given. So the actual direction actually creates here compression, because it's going inward, because it's opposite to this direction. So it's going inward to point C, that creates compression. Let's denote it by the letter C. Yeah, now let's move to the next joint. Yeah, let's move to joint B. So joint B connects members AB, BC and BO. So let's find the distance of AB. AB will be equal to 0 square plus 10 feet square plus 7 feet square. Yeah, so 3 square. Yeah, so this will be equal to 12.21 feet. Yeah, now what about BC? Yeah, BC will be equal to 24 feet square plus 0 square, 0 feet square plus 7 feet square. Okay, yeah, this is 25 feet. Now let's calculate BO. Yeah, BO, that will be equal to 0 square plus 0 square plus 7 feet square. And this is just 7. 7 is the only thing there. So it's 7 feet itself. Yeah. Now let's calculate the values. Like the vector FAB will be equal to magnitude of FAB into vector AB by magnitude AB. That is FAB divided by we calculate the value of AB, that is 12.21, so have to be here, times 10J plus 7K, 10 into Y component plus 7 times Z component. Now FBC, vector FBC will be equal to magnitude FBC times BC, vector BC by BC, that is FBC divided by, we calculated BC, that is 25 feet, and that times the vector BC will be 24 in I plus the 7 in Z. So this is actually, we know the value of FBC, we actually calculated, yeah, we got the value of FBC, that is minus 500 lb. So just substitute the value of FBC here, that gives us minus of 480 lb along I direction plus 140 lb, let's give it back, otherwise it may get confused, along K direction, yeah. So this is it, this is FBC. Now let's calculate what, yeah, FOB, where FOB will be equal to FOB times OB by vector OB by OB, that is the FOB by 7 times OB, the vector OB is just 7 in K direction, K component direction. Yeah, let's draw the figure for better understanding. Let's use blue, right? Yeah, that will be better. If this is B, if this is point B, there is FBA in this direction at some slope, there is FBO, and there is FBC, and the BZ, yeah, and let's take D. This will be Y, this will be Z, so the perpendicular should be, this will be X. Oh yeah, there is BH also, because there is, yeah, and yeah, so we got the values. Now let's calculate, let's use 25, yeah. So component at Z direction, so component at Z direction is J. Okay, J direction. To get the component at J direction, we need to find summation along y equal to 0. That gives us 10 by 12.21 that we found. Hypotenuse 12.21, FAB plus the 200 lb. So along y direction, the one thing is that thing. So yeah, so this gives us the FAB. Therefore, FAB will be equal to minus 244.2 lb. Actually, there is a negative sign here that indicates the actual direction of FAB is opposite to the given direction. That is the actual direction. Because of the actual direction, that creates compression. So it's denoted by the letter C. Yeah. Now component component at K direction, right? Component at K direction. So to find the component at K direction, of course we have to summation along Z equal to 0. So that gives us the 7 by, yeah, hypotenuse is 12.21. Okay, this is 12.21. FAB times FAB minus 140 lb minus FOB equal to 0. So here we just found the value of FAB, substitute that value, that gives us the value for FOB equal to 280 lb. And you can see FOB is actually going outward from the point B. That creates tension. Let's denote it by the letter T. Yeah, I hope you understood the problem. Thank you.